Hello and welcome to the Daily Space for today, January 13th, 2021. I am your host, Dr. Pamela Gay, and I'm filling in for Annie Wilson. Normally, we're here bringing you science and filling your brain with that, but Wednesdays, they're meant for rockets. So let's get to it, shall we? We had a couple of launches that snuck in at the end of 2020 between Christmas and New Year's that we haven't covered yet. So let's start with those. First, on December 27th at 1544 UTC, China launched the Yaoguan 33R mission atop a Long March 4C rocket from the Xinjiang Satellite Launch Center in China. The satellite is believed to be a replacement to the Yaogan 33, which was launched in May 2019 but failed to reach orbit. The Yaogan satellites are government remote sensing satellites that can be used for tasks such as satellite experiments, by which I mean scientific experiments, land surveys, and disaster prevention and mitigation. Also on board the rocket was the Weian 2, a Chinese nanosatellite that reportedly belongs to the Shanghai Microsatellite Engineering Center. Beyond that, it's a technology demonstration payload. We really can't tell you anything else about it or its mission or configuration. We can, however, show you the launch. Orbit at an altitude of 480 kilometers. It will be used to acquire extremely high-resolution images in the visible and infrared bandwidths, day or night, and in fair weather, and using a variety of imaging modes to meet as many operational requirements as possible. This was the 10th and final launch of 2020 for Arianespace, and their 5th launch last year to use a Soyuz medium launcher. And here's a video of the launch.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top, décollage.
With that fabulous launch, after this break, we'll be back to talk about the first launches of 2021. The first launch of 2021 took place on January 8th at 2:15 UTC, when Turksat 5A was launched on board a SpaceX Falcon 9 rocket from SLC-40 launch pad at Cape Canaveral Space Force Station. This was not an entirely new rocket. The Falcon 9s have the ability to reuse their first stage and sometimes their fairings. This launch included the 4th flight of Booster 1060 and was the 104th flight of the Falcon 9. The booster made its 4th landing on the drone ship, named Just Read the Instructions. It was about 8.5 minutes after launch. For those of you keeping score at home, the fairings were both previously flown and both were recovered from the water. Turksat 5A is Turksat's first geostationary communications satellite built at the new Turkish Aerospace Industries Satellite Assembly Integration and Test Facility, UMET, in Ankara. It is based on an all-electric version of the Eurostar E3000 satellite platform made by Airbus Defence and Space, and about 20% of the technology is Turkish in origin. Unlike the traditional communication satellites, Turksat 5A uses several small electric thrusters to reach its final orbit instead of some form of a single large bipropellant engine using fuels like nitrogen oxide and hydrazine. This increases the amount of time it will take to reach its final geosynchronous orbit from a week or so to months. What the mission lacks in zip, it makes up for in slick design. These electric thrusters substantially reduce the satellite's weight. This reduction allowed it to be launched on a smaller and less expensive Falcon 9. From its future location at 31 degrees east in a geostationary belt, Turksat 5A will use 42 Ku-band transponders to provide telecommunication and direct TV broadcasting services to much of the eastern half of the Northern Hemisphere. If all goes well, this mission is designed to function for the next 15 years. Turkish officials have reiterated their plans to launch its sister satellite, Turksat 5B, in June 2021, also with SpaceX. Here is a video of launch from Cape Canaveral Space Force Station.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. And liftoff.
Stage 1 chamber pressures are nominal. The vehicle is pitching downrange.
And we can't miss a chance to see the fourth landing of Booster 1060.
And back on sea level, you can see here the drone ship. We have confirmation of go orbit on the second stage, and looks like we have a good landing on the drone ship as well. This is SpaceX's 71st successful first stage recovery. This particular booster's fourth successful recovery, getting ready for its fifth flight in the future.
This SpaceX flight also carried a camera that allows us to see the satellite deployment, so let's also take a look at that.
Payload deploy confirms.
And you can see it. We have confirmation of successful payload separation of the Turksat 5A satellite, and that will now bring...
We're now going to go to commercial, and when we come back, we're going to look at a new proposed design for satellites made, I kid you not, of renewable materials. By which I mean, they're made of wood. Hello, everyone, and welcome back. Joining me now is Gordon Dewis, one of the writers that you don't usually see up here on camera. And he's here because he brought a really cool story to all of us a couple of weeks ago about how there are possible plans to build spacecraft out of wood. Can you tell us a little bit about the background on this, Gordon?
So, an astronaut, a former astronaut, Takeo Doi, is a professor at a university in Japan, and he is looking into how to reduce space junk and the problems that happen when satellites re-enter the atmosphere. They burn up, and they create tiny aluminum particles which float around in the upper atmosphere for years, and this is bad. Eventually, it'll affect the environment on the Earth. So they are exploring alternative materials to the traditional materials used in a satellite, which is largely aluminum, and they're looking at wood.
And this is a collaboration between Kyoto University and Sumitomo Forestry. And one of the really interesting things that I found in all the literature that I hunted down, going down a rabbit hole on the internet, is they're currently being very coy about what kind of wood they might possibly be using, and what are some of the problems that they have to figure out how to somehow solve to make this problem work.
So one of the things about wood is it's a living material, or it was a living material. Once they cut it down, it's not really living anymore, but it's made up of cells. And so the cells have water in them. And as the wood dries out, it can change shape. It can change length. It can shrink. It can warp. And if you're making a satellite, that's a bad thing. So you need some sort of wood that is very stable, that won't outgas, because that's a major concern when you build a satellite, is the gases that come out of all the materials that are used can interfere with the sensors on the satellite. And if you have a wooden satellite sitting on a launch pad on top of a rocket, some of those fairings are not sealed against the humidity, so
and
there could be
fairings,
humidity.
fairings
So-
are the enclosure, the petal-shaped flaps, for lack of a better word, pieces.
The cover.
Yeah, they create that nose shape at the top of the rocket that is largely there to make the rocket aerodynamic. If you ever saw The Martian, you know those are only needed because of air. If you have a humid day, and Japan can be a fairly humid place to be, that wood can reabsorb the moisture. And anyone who's a musician in our audience knows that temperature variations, humidity variations, they all cause wood to change shape. So this is a very complex problem they're taking on. We do worry about metals warping and changing shape with temperature as well, but humidity isn't the same kind of an issue. What exactly is the balance between figuring out how to solve the problem with wood and the problem that we're experiencing with metals?
So I think one thing is they are initially, there's an image. If you Google this, you'll find the image of a little CubeSat. It's probably about 10 centimeters on an edge. And it's a little wooden box. That's what's in the picture.
And we'll
For
provide
small-
the picture on our
yeah.
website.
For small satellites, for small components, it's probably not as much of a concern. But if you were to start to scale this up and make, use larger pieces, longer pieces, the change because it's made out of wood as opposed to made out of aluminum, which is probably very well understood compared to wood and how it reacts when you heat it up and cool it down. The changes for spaceborne wood could be quite significant. So they haven't said what type of wood, what species they are planning on using. I imagine they're doing tests to try out different types. But whatever they pick is going to have to be stable that way. And that's probably the biggest challenge.
And this is going to be a matter of how you trade off different factors. Wood has some really nice characteristics compared to metals. For instance, when it moves through a changing magnetic field, which kind of defines orbiting the planet Earth, you don't have to worry about wood generating current as it moves through that changing magnetic field. You also don't have to worry about the metal cage, which blocks the electronic signals from whatever's going on inside. That acts like what's called a Faraday cage. This is why if you're on some airplanes, your cell phone stops working. Well, with a lot of satellites, you have to put your antennae on the outside of the spacecraft to be able to communicate with Earth, because that metal shell insulates the insides of the satellite from those signals. With this, you can pack everything inside the enclosure. It really feels like this is a solution more for CubeSats and microsats than for bigger satellites.
And you're right. I think it is. Initially, they're going to be working with CubeSats because they're small, they're easy to make. You can make many of them, pack them into, the same size as you would have a large satellite, and get more bang for your buck in terms of research platforms. The satellites will be lighter compared to one that's made out of traditional materials, most likely because wood is less dense than aluminum. But when you have that nice Faraday cage around all of your electronics and you take it away, now you're going to have to start thinking about, how do I shield my electronics? Because cosmic rays are present in space, and they can seriously interfere with electronics, from just flipping a bit that might cause a reset to completely knocking your satellite payload out of operation. So there are trade-offs. There really are trade-offs, and I think that we're looking at nanosats initially.
And what excites me about this is, with nanosats, microsats, and even some CubeSats, the prices are low enough that you can start to see universities easily participating in creating class projects that are launching a small satellite. This is multi-semester capstone courses, not your freshman lab. But you can still have students launching missions. And with wood, you have the chance to prototype things over and over at a significantly lower cost, and to start using straightforward fabrication, such as maybe not a glow forge because you don't want your sooty edges, but CNC machines are quite common for wood and less common for the metals. This is going to make the machine shop a less intimidating place for a lot of people just learning how to create missions.
Yeah, I think right now you can buy essentially a 1U CubeSat kit. You can buy all the components, and then you just fit your electronics into it. I sort of, when I think about what would a wooden 1U CubeSat kit look like, I almost think of those, the balsa wood model planes that you had, where you had the piece of wood that had all the little scores, and you just punch all the bits out, you clip it together. That's what springs to mind. So they will be lighter, and that's good. It might mean you can fit more on the top of the rocket, and maybe use less fuel, use a smaller rocket. So that's sort of the benefit, I think, of using, in addition to not having the satellites burn up and become little particles of alumina floating around in the top of the atmosphere. I think that's one of the benefits, is you'll have a lower amount of energy needed to get off the ground.
Now,
no, go on.
Now, one of the concerns that is always in the back of my mind, and then I have to remember the facts, because our guts often worry about things that our brains know we don't need to worry about. It often feels like we're launching rocket after rocket into space, getting rid of all of this metal. We're launching spacecraft after spacecraft into space, and we're either leaving that metal in space or we're burning it up as it passes through the atmosphere. And it feels like, where we're dealing with recycling, reusing being such an important value moving into the future, that we're throwing away resources. But the total amount of metal that's gone into space throughout history is less than would fit inside a large skyscraper.
That's true. That's true. And of the things that are being launched into space, and all the objects that are in orbit around the Earth, a significant number of them are not payloads. They are bits of the rockets. They're rocket boosters, they're rocket bodies, they're toolkits that have floated off from the ISS. All of these things, I mean, if we say, okay, well, we're going to start making wooden satellites, that's great, but we can't make wooden rockets. I don't think we can make wooden rockets. We're not doing that anytime soon. And so we still have all that metal up in orbit that will eventually come out of orbit. The satellites you can predict, or satellites you can bring out of orbit if you need to at the end of life. And I believe, and that's the agreement that many satellite launchers have now, is they have to have an end of life plan. It's
And
harder for the rocket bodies because they don't have control over those.
And this is going to become more and more of a problem as we look to the future. Currently, we are already seeing Starlink and several other companies beginning to launch their space-enabled internet constellations of thousands of missions. Amazon is now looking to plan out their own Kuiper version, and as we do this, we're probably going to see more and different kinds of materials considered. SpaceX has looked at carbon fiber and discarded it in favor of steel for some of their missions. We've seen ceramics used in the past. Do you have any guesses on just what's going to happen beyond some test missions for wooden spacecraft of the future?
Wooden spacecraft. I think that you're going to see them used more in educational applications. You might see little mini constellations of very small satellites, microsats, nanosats, made out of wood because they'll be inexpensive and they're not a concern at the end of life. I don't see it at this point in becoming a major building component in larger, more conventionally sized satellites. Maybe you could use it for like micrometeorite impact protection, where now they often use some sort of aluminum, multi-layer aluminum foil thing to absorb all that energy. Maybe they could use that. Maybe they could use wood, and that might make it easier to repair, to replace panels when they do get damaged.
And right now, this is all entirely pie in the sky, and I am
Yep.
asking you to make wild guesses. It's going to be interesting to see what Kyoto University and Sumitomo Forestry come up with in the next few years. This is a short period program. They're hoping to have something launched by 2023. The program's currently scheduled to end in 2024. But sometimes thinking crazy leads to amazing new things. They have major problems ahead, but I look forward to seeing how this develops. And as it does, we'll bring that information to you right here on the Daily Space. But for now, we're going to go to break. And when we come back, we're going to have a rundown of the current stats for launches in this brand new year. To wrap things up, here's a running tally of a few spaceflight statistics for the current year. Toilets currently in space, 5. 3 installed on the International Space Station, 1 on the Crew Dragon, and 1 on the Soyuz. Total satellite launches, 1. 2021, it's off to a great start with exactly 1 launch attempt, and it made it. We keep track of orbital launches by where they launched from, also known as spaceport. Currently, the breakdown is we've had just 1 launch, and that 1 launch was from here in the United States. And your random space fact of the week is SpaceX has a Boston Dynamics Spot, a robot dog. They have a robot dog, people. It appeared in video on YouTube that was posted by Lab Padre. In this single frame screen capture, you may, if you squint, just be able to make out the robot as it checks out the debris from the Starship SN7 prototype. This particular incarnation of Starship was purposefully pressurized to its maximum pressure, and it popped, while clouds of nitrogen still billowed around the ruptured prototype. The robot dog was caught marching around the launch pad and inspecting the still dangerous site. SpaceX has named their robot Zeus, and we will link to Lab Padre's video from our website, dailyspace.org. I, for one, look forward to seeing more of our robot safety inspectors. And thank you for watching. This has been the Daily Space.